Hey everyone, a very good morning and welcome back to my channel. So let's start with the today's question. This is the question number 3.86 of Leetcode, maximum total damage with a spell casting, right? So in this question, there is a magician who have various spells, right? So we are given an array power which is denoting the power of each element represent the damage of the spell, right? Where each element represent the damage of a spell. So multiple spell can have the same damage also. Simply they want to say in an array you can have duplicate elements, right? So we are known that if a magician decide to cast a spell, or if I want to choose an element from a array whose value, or you can say damage, is equal to the power of I, then I cannot take any other element which is equal to the power of I minus 2, power of I minus 1, power of I plus 1, or power of I plus 2, right? So basically you cannot take any element which is just within the range of 2, to the left and to the right, right? So if I'm deciding to take one particular element, then I have to check for left and right also, that it should not be in the range of 2. Okay, so each spell can be cast only once, right? So you can take each spell only once. And so yeah, we have to return the maximum possible total damage that a magician can cast. So simply we are given an array, or just think like you want to take the sum of subsequence, and you are given some condition that if you are taking one element, then you cannot take these four elements, right? Which are just within the range of 2 of that element, right? Now if I decide to take one element, then I cannot choose all those elements, and I have to choose elements such that my overall sum will be maximum, right? So basically I have to maximize my sum, or you can say my total damage. So let's consider simply this is sum. Now in the question it was mentioned that multiple spell can have a same damage. So simply they are saying an array can have duplicate element, right? So suppose I decide to choose a number, and it is also having some duplicates in the array, right? So definitely I'm not allowed to choose a number which is just 2 greater than, or less than a number, right? But I'm just allowed to take the copies of that number, right? So I will definitely take them because I have to maximize my total sum, right? So if I'm taking a number, then definitely I'm going to take the copy of that number, or you can say duplicate of that number, right? Because I want to maximize the sum, and if I'll take the duplicates also, then this will only maximize my sum, right? So I'm just saying, why to consider the duplicates individually, right? Because I'm sure that if I'm taking a number, then definitely I will take its duplicate for sure. So I'm not, I am not, I should not consider each number and its duplicate individually and process it individually. In fact, I can just consider them in just one process or something. Okay, so basically here we were just considering the entire power array. So I'm saying in place of this entire power array, why not only care about the unique elements, right? Because the duplicate, I'm just definitely going to take them. So I'm not concerned about the duplicates. I will just take out the unique element from this power array, and I will simply count the frequency of each element, right? So suppose in this array, if I decide to take one, then let us say this was my original array. Okay, now I just count the frequency. Okay, so now I'll just count the frequency of each element, and you can see here is the frequency of one is 2, and frequency and 3, and frequency of 3 and 4 is 1, right? So I'll simply take out the unique element from the array, so which are 1, 3, and 4, right? Now suppose if I decide to take 1 here, so my sum is going to be 1, right? But I am sure if I'm taking the one, then definitely I'll take its duplicate as well, because it is not causing any loss to me, right? I will always be at profit. So I'll definitely take the duplicate. So I'll say 1 into frequency of 1. So this is the way we are going to take element. Okay, so yeah, we will be considering only the unique element, and we will take out the unique element from the array. We will just calculate the frequencies, and now we are only concerned about the unique element. Okay, so instead of having duplicate element in the array, now consider my array having only unique element. Now as you can see, from the after reading the question, you will simply understand this is the question of DP, right? Because if there is a something like take or not take in your question, then definitely you should go with the DP. Okay, so here at each element, I'll think if I want to take this particular element or I don't want to take. Now once I decide to take this element, I have to make sure I'll just follow all the given restrictions here, right? Like suppose if I want to take element, then I cannot take the element which is 2 lesser than or 2 more than my number, right? So I'll have to keep I'll have to take care of all this also. Yeah, so suppose what if I say just let me sort the array and decide to process each element sequentially, right? Because if my array is sorted, then I will not be if my array is sorted, then I am not concerned about the previous element, or you can say the element at left, right? Then I'm only concerned about the right element, because I'm sure if I have moved to a particular element, then I have already kept the restrictions in mind while I was processing the previous element, right? Like suppose if my this particular array is sorted and I have 1, 3, and 4 in my array, right? Now, suppose there is also 2. Okay. Now, if I decide to take, if I'll just now suppose if I'm at an index 1 and I have two options, if I want to take one or if I don't want to take one, right? So suppose I decide not to take one, right? So I'll move to 2 definitely. Now when I am at 2, I'm not concerned about the this particular thing, like power of 2 should be like power of I minus 2 or power of I minus 1, right? I'm not concerned about these two cases, because if I have moved to 2, then I have then like suppose if I'm moving to 2 from 1, then definitely when I was at 1 I have considered these cases, then only I move to 2, right? So now we are not concerned about the previous element. Now we will be left with only two cases which I need to check here, which is if my next element is having a power greater than 2, then I have to check if it is just within a range of 2 or not, right? Or suppose simply you can say if my array of I plus 1 minus array of I is greater than 2, then only I'm going to jump from array of I to array of I plus 1, right? Otherwise, I am not allowed. Now, suppose if this doesn't happen, then definitely I'll go for the next index and I'll check if my array of I plus 2 minus array of I is greater than 2. Now, I'll check again. If this is also not happening, then I'll go to array of I plus 3, right? And I am sure this particular element will always be uh, 2 more than my current element. Why I'm saying this? Because I am sure my array has only unique element, right? So even if there is a gap of 1 between each element, then the third element will always be 2 greater than your current element, right? Because if you are having a gap of 1 1, then definitely your gap will become 3 when you come to the third element, right? So if I will check for the array of I plus 1. If it is satisfying my these two cases, then I will consider my array of I plus 1, right? If now I'll check, otherwise if it is not satisfying, then I'll move to the array of I plus 2 and I will check again. Like if it is satisfying my these two cases, then I'll move to array of I plus 2. Now even if it is not satisfying, then I'll move to array of I plus 3. And now I am sure my array of I plus 3 is a valid index that I can move after array of I, right? So this is my take case where I was going to take array of I. Now suppose if you are not going to take array of I, or suppose you are at a particular index and you decide not to take it, then simply you can move to the next index, right? Because there is no constraint. So simply you can move to the next index, right? So this is something we are going to do. So let's start coding now. Okay, so initially what we were supposed to do, simply we had to find out the frequency, right? So let's make a map where I will be storing frequencies of each element of my array, right? So this is my map. It will be storing frequency. Okay, now I'm done. Now I will make a vector where I will be storing only unique element, right? So let's call it array. Okay, now from for all the unique element which I have stored in map, um, I'll simply put them into my vector, right? Okay, so I have put them into my vector. Now let me sort my vector because we were considering the elements sequentially, right? Because I don't want to consider the previous two restrictions which we had, these two restrictions. That's why I have shorted my array and now we don't care about them, right? So I will just short my array. Okay, and let's say this is the size of my array after we have considered only unique element, and let's say I have declared my n here. Okay, now once we have filtered out the unique element, we will run a function for memoization. So let's say this is my function which will definitely return the maximum sum you can get after considering all the elements from my array. So okay, so this is my dp vector. Now suppose if my I exceeded the value n or it goes out of bound, then I will simply return 0. If my value is already stored in dp, so if dp of I is not equal to -1, I'll simply return dp of I. Now let's consider here two cases which we have talked about. These are the take or not take case, right? So if I am taking a particular element, then I am sure that I will take this element and all the duplicate element or all the copies of that particular element, right? Because we want to maximize. So simply we always try to take as many element as we can. So if some copies of a particular elements are available with you, then why not to take them, right? So simply you will take off all the copies of array of I which is stored in the map of array of I, as I have stored the frequencies, right? So this is my take case. Okay, now suppose if I don't want to take, so this is my not take case, and initially it is 0 for now. Okay, now let's consider a take case first. So suppose if I'm taking my array of I, now I have to check if I can move to array of I plus one element, because I have to make sure these two conditions should not violate, right? So if I'm moving to array of I plus one, then I will check these conditions, right? So suppose I want to move to array of I plus one, so I have to check if array of I plus one is less than m, because it should not go out of bound, right? Now I have to check if array of I plus 1 minus array of I is greater than 2, then only I will be able to move to array of I plus 1, right? So this way I'll move to array of I plus 1. This is my array and take. Okay, done. Now suppose if this doesn't happen, or suppose if my array of I plus 1 is like just one or two number greater than just if the difference between the array of I plus 1 and array of I is less than 2, then I cannot move to array of I plus 1, right? So then I have to check for the array of I plus 2. So simply I will check if array of I plus 2 is less than n, and difference between array of I plus 2 and array of I should be greater than 2, right? And if it is valid, then only I will move to array of I plus 2, and I will say, yeah, this is something. Sorry. Okay, so this is array of I plus 2, array, and db. Okay, now if these two cases are not satisfied, even if I can not move to array of I plus 1 and if I can not move to array of I plus 2, then I am sure that definitely I can move to array of I plus 3. So I will simply move to array of I plus 3, which is equal to this, right? It's db. Okay, so this was all about our take case. Now suppose if you don't want to take your current element, then simply you can move to array of I plus 1, where there is no restriction for you because you are not taking current element, right? And in the end, we will be returning simply maximum among them, right? So I'll take maximum of take and not take. Okay, so this was the maximum and I have taken it. I have sorry returned it. Now let me make a dp vector here, which will be of size n. uh, this will be of size n, and initially all are -1, and after this I will return what I will get from this function as a return value. Initially this is 0. Yep. So this was the solution. Let me run it first. Okay, so this is giving wrong. Oh yeah, actually there was something missing. I should have written not take plus equal, because this is the not take case, right? So we have to add whatever we are getting in this answer. Okay, so let's run it again. Now it's working. Yeah, it's working fine, right? So yeah guys, it was the solution which we have done for this question. Now if you have any doubt, you can ask in comment box, but before that let me just summarize what I have done. Basically we were given an array and we were given some condition which was as follows, like if we are choosing an element, then we cannot choose element with the power as given here, right? So we only had to make sure that we are just maximizing our power or the damage, we can say, right? So I have to basically I have to maximize my sum. So initially I decided to consider only the unique elements, right? Because I was sure if I want to maximize the sum, then I'll definitely take the duplicates if I'm taking element. So I'll just count the frequency of all the element, and if I'm taking the element, then I'll simply just multiply it with the frequency, because I'm sure that I will take the duplicates as well, right? Now I short the array, because if suppose if you are at a particular index I and you choose that index, right? So if you are moving to the next index, then definitely you cannot move to any index which is just uh, 2 greater than or 1 greater than your current index, right? So you will make sure while moving. Now once you moved, you are not supposed to consider the previous cases now, because if you have moved to a particular index, is definitely you must have considered these two cases also, right? So now you are not concerned about these two cases. That's why I have shorted the array, because after shorting the array we only have to check these two cases, right? So here we basically minimize the checks, and we'll just consider all the cases in my take case. And if I don't want to take element, then we are not supposed to take care of anything, and we will simply move to the next index. And in this way we were able to find the maximum sum as possible with the help of dp, and we simply returned it, right? So this was the entire solution. Now still if you have some doubt, you can ask in comment box. I will be providing you the solution and the question link, right? So thank you so much for watching. Have a good day.